Diodes have two terminals and are used when you want current to flow only in one direction. There are all kinds of diodes, but here we're only going to be talking about the simplest one, a silicon PN diode. You can also find PN diodes made from germanium, but they're about as common as somebody who weighs 100 pounds and wrestles in the WWE. You just don't find them that often. You can really see how a PN diode works by looking at the curve of the current it conducts with respect to the voltage across it. A silicon diode will really start to conduct at about 0.7 volts applied in its forward direction. That 0.7 volts is called the threshold voltage. If the voltage is applied in the reverse direction, there's only a tiny amount of current flowing. And things stay that way until you reach a breakdown voltage. Though all silicon diodes start conducting hard at 0.7 volts, the breakdown voltage varies. You have to look it up in the spec sheet. We can show that behavior with a simple voltmeter. This one we have here has a setting for checking continuity where it applies a small voltage to whatever is connected to its leads. If we put the leads across a diode in the forward direction, we see the 0.7 volts on the display, meaning the diode is conducting current. If we reverse the leads, the diode basically looks like an open circuit to the DVM. No current flows. Now the diodes we have here have a lead on each of their terminals. But these days, the only place you tend to see diodes with leads on them is in YouTube videos like this one and in home projects. If you look on real circuit boards, the diodes are going to be in surface-mounted packages, often SOT23 packages like the one shown here. You'll also find arrays of diodes packaged typically in 8-pin packages. The usual application for those is in conducting transients or noise to ground on data lines. If you're designing a circuit that contains a diode, you might use the equivalent model of a diode for planning out the circuit. The simplest one tends to contain a small resistance that represents the resistance from the leads and other components in the diode package, and a voltage source representing the 0.7 volts at which the diode turns on. There are more complicated models that represent diodes when they're at higher frequencies, and they have capacitors and inductors representing the various parasitic elements. Finally, we'll mention the first diodes, which were actually vacuum tubes. The way these worked was that there was an electron emitter in the tube surrounded by a plate designed to pick up the electrons from the emitter. The electrons hitting the plate constituted the current flow. Current couldn't flow in the opposite direction because the plate had a much bigger area than the emitter, so the emitter picked up very few of the electrons the plate spewed out. And that was the behavior that solid-state diodes we have today basically mimic. For more videos like this, check out eeworldonline.com.